Imagine if every drop of water floating above your city could be captured before it ever became rain. It sounds like science fiction, but around the world, scientists are already building machines that pull drinking water directly from the air. Some use cooling systems that condense water vapor. Others use advanced materials that absorb moisture, even in deserts. The technology is real, and it's improving every year. But it raises a fascinating question. If humanity starts harvesting enormous amounts of water from the atmosphere, could we accidentally change the weather itself? To answer that, we first need to understand something surprising. The sky isn't empty. At any given moment, Earth's atmosphere contains around 13,000 cubic kilometers of water in the form of vapor. That's enough water to fill millions of Olympic swimming pools. But it's only a tiny fraction of Earth's total water supply. Less than 1/100th of 1%. And unlike lakes or oceans, atmospheric water is constantly moving. Every molecule is part of an endless cycle. The sun heats oceans. Water evaporates. Winds carry that invisible vapor across continents. Clouds form. Rain falls. Rivers return the water to the sea. Then the journey begins again. Every second, this cycle moves staggering amounts of water around the planet. Scientists estimate that roughly 500,000 cubic kilometers of water evaporate and fall back to Earth each year. It's one of the largest natural systems operating on our planet. Now imagine removing water before it finishes that journey. Would less vapor mean less rain? The answer is much more complicated than it seems. Today's atmospheric water harvesters are surprisingly small compared to nature. Even the largest systems produce thousands, or sometimes tens of thousands, of liters per day. That sounds impressive, until you compare it with a single thunderstorm. An average thunderstorm can contain hundreds of millions of liters of water. Large storm systems move billions of tons of moisture through the atmosphere. Compared to that, today's harvesters are almost insignificant. If every atmospheric water generator on Earth disappeared tomorrow, weather forecasts wouldn't change. Scientists wouldn't even notice. But that's today. What about the future? Imagine millions of atmospheric water harvesters spread across deserts, cities, and farmland. Could their combined effect become measurable? Scientists are beginning to explore exactly that question. Because weather isn't controlled by a single cloud, it's controlled by delicate balances: humidity, temperature, air pressure, wind. Even small local changes can sometimes influence larger systems. For example, forests constantly release water vapor through a process called transpiration. The Amazon rainforest creates so much moisture that scientists often describe it as a giant biological pump. Some of the rain falling hundreds, or even thousands, of kilometers away originally came from trees. When forests disappear, rainfall patterns can change. This shows something important. Changing where water enters or leaves the atmosphere can affect local climates. But atmospheric water harvesting works very differently. Instead of removing huge amounts of moisture, it removes tiny amounts from enormous volumes of air. Most climate researchers believe that, at any realistic scale over the coming decades, atmospheric water harvesting would have little to no measurable effect on global weather patterns. The atmosphere is simply too large, and the water cycle is far too powerful. However, local effects are more difficult to predict. If enormous harvesting systems were concentrated in one region, especially dry regions already sensitive to humidity, scientists would likely study whether they influence local fog, morning dew, or small-scale cloud formation. At the moment, there is no convincing evidence that existing atmospheric water harvesting projects significantly reduce rainfall. But researchers continue monitoring the technology as it develops, because history has taught us something important. Humans rarely intend to change the environment. Sometimes, it happens anyway. Large dams reshape rivers. Cities create heat islands. Deforestation changes rainfall. Even tiny airborne particles can influence cloud formation. Our planet is full of systems connected in ways we don't immediately recognize. That's why atmospheric water harvesting is receiving growing scientific attention. Not because it's dangerous today, but because understanding its long-term effects before global adoption is simply good science. Ironically, the greatest environmental benefit may outweigh the risks. These systems could provide clean drinking water without pumping groundwater, without transporting bottled water, and without relying on rainfall. In regions facing severe drought, they could become an important part of future water security, especially as climate change makes fresh water less predictable. So, could harvesting water from the atmosphere change Earth's weather? Based on everything scientists know today, probably not. At least not on a global scale. The atmosphere moves too much water, too quickly, for current technology to make a meaningful difference. But perhaps that's not the most interesting question, because every new technology begins small. The real challenge isn't asking whether we can pull water from the sky, it's making sure we understand the consequences before we do it at a scale the planet has never seen.